You see a dog across the street, and your hand is already reaching before your brain has made a decision. You walk past a cat on a fence and you stop, mid-conversation, to run your fingers through its fur. You buy a blanket because it's soft. You stroke the velvet on a restaurant seat without realizing you're doing it. You reach out and touch things constantly, compulsively, automatically. Soft things, warm things, living things. Sometimes things that aren't alive at all. Nobody taught you to do this. You just do it. And if someone asked you why, you'd probably say something like, "It feels nice," or "I just wanted to," which is true, but it isn't an answer. It's a description of the symptom, because the actual reason you reach out and touch things goes much deeper than preference. It's written into the structure of your skin, and it has been running in mammals for over 200 million years. You don't pet things because you like them. You like them because petting activates a biological system so old and so fundamental that your body doesn't bother asking your brain for permission first. Your hand is already moving. Your brain is still catching up. Here's what's actually happening in your skin when you stroke something soft. Your body is covered in nerve endings. Most of them are designed to detect pressure, pain, temperature. Practical, useful, survival information. But buried in the hairy skin of your arms, your neck, your scalp, is a specific class of nerve fiber that serves an entirely different purpose. They're called C-tactile afferents, or CT afferents. And unlike every other sensory nerve in your body, these ones are not designed to tell you about the world. They are designed to make you feel good. That's their entire job. Nothing else. CT afferents respond to one thing specifically: slow, gentle stroking at around 3 centimeters per second. Not poking, not pinching, not a firm handshake. Slow, soft, deliberate contact at roughly the speed of a gentle caress. That specific sensation, and almost nothing else, triggers these fibers. And when they fire, they skip the part of the brain that processes information entirely and go straight to the regions that process emotion, triggering a release of oxytocin and endorphins that produces an immediate feeling of warmth, calm, and connection. Your skin has an entire nervous system built specifically for touch that feels like love. You've been walking around with it your whole life and nobody told you. In 2013, neurobiologist David Anderson at Caltech published a study in Nature identifying a related class of neurons, MRGPRB4+ neurons, linked to hair follicles in the skin of mice. These neurons responded only to gentle stroking, not to any other form of contact. Poke the mouse, nothing. Stroke it slowly, the neurons light up. The study confirmed that humans have equivalent neurons in the hair-covered portions of our skin. So the sensation of petting, giving it, or receiving it, isn't just pleasant. It is processed by a dedicated biological system that exists for no other purpose than to make touch feel meaningful. Evolution doesn't build things for no reason. So why build an entire nervous system inside your skin wired specifically to respond to gentle touch? The answer is grooming. For social mammals, primates especially, grooming is not hygiene. It is the primary currency of social life. Chimpanzees spend hours every single day running their fingers through each other's fur. Hours, and for a long time researchers couldn't figure out why, because the time investment is enormous and the hygienic benefit alone doesn't come close to justifying it. It turns out the answer wasn't about cleanliness at all. In 2013, researchers at the Max Planck Institute for Evolutionary Anthropology measured oxytocin levels in wild chimpanzees before and after grooming sessions. When a chimpanzee groomed a bond partner, a specific animal they were allied with, oxytocin levels spiked significantly. When they groomed a non-partner or didn't groom at all, the spike didn't happen. They weren't picking out parasites. They were doing therapy on each other. The touch triggered the chemistry deepened the bond, and the bond determined who had your back when things went wrong, which in the wild they always eventually did. Your CT afferents are the same system. The biological hardware that made social grooming rewarding enough that primates kept doing it for millions of years. You inherited it, and it still fires exactly the same way it always has, except now you're running ancient primate bonding software on dogs, cats, blankets, and the velvet armrests of restaurant chairs. Which raises the obvious question: why does touching a soft blanket feel good? The blanket is not your ally. The blanket is not going to protect you from rival groups. The blanket has no oxytocin. So what's happening there? This is where a second system kicks in. Research has shown that touching soft objects, regardless of whether they're alive, measurably lowers cortisol levels and reduces heart rate. Your stress response physically changes just from the texture. Brain imaging shows that touching something soft activates the orbitofrontal cortex, the same region that responds to good food, beautiful music, and anything else your brain categorizes as a reward. Your brain, it turns out, does not fully distinguish between a living creature and a soft object when processing pleasant touch. It just registers. Soft, gentle, safe, and then it calms down accordingly. The blanket doesn't know it's doing this. Your brain doesn't care. There's also something called Kinchin schema, baby schema, first identified by ethologist Konrad Lorenz. It's the specific set of physical features that trigger nurturing behavior in humans. Large eyes relative to the face, round, soft features, small nose, plump texture. Babies have these features. So do puppies, kittens, and most animals humans instinctively want to touch and squeeze and generally bother. When your brain detects these features, it releases dopamine, before you've consciously decided to do anything. The decision comes after, if it comes at all. This is why you're crouching down to pet a stranger's dog before you've asked if it's friendly. The dopamine already voted. And here's where all of it connects. The CT afferents, the MRG-PRB4 plus neurons, the oxytocin, the orbitofrontal cortex, the Kinchin schema, none of these systems were originally built for petting dogs or stroking blankets. They were built to keep social animals alive, to make physical closeness feel good enough that mammals would seek it out, maintain it, and fight to preserve it. Because in the world these systems evolved in, being cut off from the group was a death sentence. An animal that found touch rewarding stayed close, stayed bonded, stayed alive. An animal that didn't. You are the direct descendant of every mammal that found touch rewarding enough to keep reaching for it. The instinct never left. It just ran out of things to groom and started reaching for whatever was nearby and soft. Robin Dunbar, the anthropologist behind the social brain hypothesis, has argued that for humans, touch replaced grooming as the primary bonding mechanism, as our social groups grew too large for everyone to physically groom each other all day. Language helped scale that up, but the underlying biological need for contact, for softness, for the specific feeling that something is safe and close, never got the memo that civilization had arrived. And so you reach out at the dog, at the cat, at the blanket, at the smooth, warm stone you pick up on a beach and turn over in your hand for no reason you can name. You're not being irrational. You're not being weird. You are running a 200-million-year-old mammalian bonding program in a world it was never designed for, aimed at whatever soft thing happens to be in front of you. The next time your hand moves towards something before your brain has caught up, you'll know what that is. It isn't a quirk. It isn't sentimentality. It's ancient. It's biological. And it has absolutely no intention of stopping.